All right, ladies and gentlemen. So in the last video, we went into some details. We're going to go into some more because we're nowhere near done yet. So now that I've explained to you through all of these various videos how it is exactly that we get to my theory and what the basic details are, now I'm going to explain to you how this actually works and how it explains the motion in real detail, tracking a single object through our solar system. So imagine, if you will, that we have our solar system. But outside of that, we have a positive field of energy that is pushed by all of the electrons that are pushed out by our sun that are positively charged. They are not likely to travel as far as the negatively charged electrons. Now, it's not that they won't travel as far, it's just that they don't hold on to as strong a charge for as long. It fades away sooner. Therefore, we will have a ball that is our Earth, a ball that is our magnetic field, a bigger ball that is the area that our sun pushes out in light, that is charged particles that are positively charged. Then outside of that, an even bigger ball that is negative. So as an object comes through, this object starts pushing into the solar system. Now, as soon as it enters this negative field of charged electrons that have some charge left, it starts a circuit. A circuit means electrons need to push-pull. When we talk about a positive negative, I went into that in one of the videos, they require a push-pull. In fact, it's the only way we can get electricity to move, and normally for that we need a draw. Once there's a draw, we get a push of electrons, and as long as we give it a circuit to pull back on, we get a flow. Now here's the problem. We don't normally think of our solar system as a circuit, but we actually need to, guys, and here's why. We're going to bring the light, because as this pushes through, it now creates essentially a circuit of electrons that are charged, where they are all negative electrons, but it's what we call a negative loop circuit, which means it's all negative electrons, but we have a push-pull. This is pushing. The push is forced, like as if we had a draw on the other end, and now the electrons start to move. And what I mean is, according to particle physics, when two electrons are next to each other, and one starts to push, the other will automatically respond. The negative charge will be transferred, the positive charge will transfer. We can't control that. It's just the nature of physics, and it's very cool stuff. And so we know that when we start to push a current, there's going to be a response from the other direction of electrons. And I think what's happening, and I know what's happening, is when we enter an object into that negative field, it starts to push electrons, which means, and I mean physically, not only is it getting charged negatively, but its physical mass will push a volume of negatively charged electrons, which is pretty substantial. And that pushback will be the same as electricity being forced through a circuit. In fact, it'll operate very much the same way electricity goes. And we should look for the maximum velocities achieved to be very similar to what we see in lightning strikes, because it is the same principles that are forcing us this surge of electrons. And if I'm right, that should be the maximum speed, is the maximum speed that electrons can transfer at. That's it, because that's all that's at force. Well, if I'm right, that's it, until we get to the point where electromagnetism takes place and we have an actual magnet being affected by another magnet. Now, long before that happens, we have charged particles. And we can have charged particles without a real magnet. It can still create a circuit and be electricity. Don't forget that. Electricity isn't magnetic, but it's still electricity. Light is electrically charged. It still travels as a wave and as a particle and as a beam, and it is traveling as electricity. And that means this is going to apply. So now that we've tracked it through the outer section, as it gets to the negative, it gets more steadily charged with that negative charge. And as it does, it starts to be attracted to the positive side of this field, at which it's now heading towards at increasing velocity, which is great because it's still sucking it forward. And at no point does it stop pushing electrons. It's always pushing electrons. Now, electrons are neat. When we push electrons, they like get out of each other's way and push each other forward. It's why lightning goes so fast. It's a pretty magical process, and it's erratic. It's path of least resistance kind of stuff, like water going over terrain, but it's very cool. And it works. And it means that this is happening for sure, whether we accounted for it or not. And we aren't accounting for it in the math, Mr. Avi Loeb, which is what we need to do. So Now, light having generated all these charged particles, our magical sun, we now have this negative and then positive, or positive and then negative field, depending on which one proves to travel farther. But in either case, it works the same, because as they travel through, once the circuit is started, that push pull is begun, believe it or not, the mold is cast. Because the moment it starts into that circuit and that push pull of electrons has begun, it's slingshotting it forward. And now it's magnetizing it and pushing it towards a positive field of electrons, which makes it go even faster. Now, as it punches through all that, it's still push pulling electrons, and that whole process is still accelerating it, which means we're seeing a combined process of acceleration, which explains not only the amount of acceleration, but the fact that they accelerate predictably in stages. And any object, even if it's not magnetically charged, guys, will be exhibiting these features because it is coming into an electrically charged field, creating a circuit by being an outside object that is pushing electrons unnaturally. And that is the trick. All of the other things in our solar system are already charged. They're already in this field. And an outside object has spent hundreds of thousands, maybe millions of years, maybe 1,000 years outside of our solar system in space that's deep space, where it's not getting directly charged by a sun. And that very fact means that it has a neutral charge. Any charge that was on it would have dissipated. And it's coming in cold, open to the charge that it's going to take. And that is my theory. And in essence, that is what's happening, guys. So as that comes toward our sun, this is where it gets interesting, because now each of the planets have their own electromagnetic field. But that is why we don't see them just slamming into it, and why they all seem to ignore the other planets and our moon and go straight smack for the sun. We were always worried they were going to hit us, but they head for the sun. Always head for the sun, like they were driven to the sun. And we couldn't figure out why. They also seem to want to come in on our relative plane to our disk. And a weird proportion of numbers, considering we're a spinning disk in a spinning universe and they're just being shot out random. But magnetically, that's accountable by the fact that there are these weak, strong forces accounting for our alignment, almost like navigation, because these forces will be push-pulling and it will push us through. And the next thing you know, one electromagnetic field comes up against this charged object and bam, it rubs off it and can very much look like gravity. In addition, we have the spinning effect of the rotating mass also pushing out electrons and pushing out all these charged particles that this will then come and interact with. And that alone, that field alone, that rush of air is enough to blow off dust. It's enough to create effects and create additional suction or repulsion on that object based on its angle and the rate of spin of each of the objects and all that stuff. That is the truth about orbital mechanics that we're not really looking at. We're just accounting for it as gravity. That is the other part of this plan, and that is the other way that I'm going to change the way you physicists think about the universe, because you're wrong. It's not about gravity. It's about charged particles, and gravity doesn't exist except on a planet. Now, this being said, I know that you guys understand this in modern physics. I'm just getting people up to date. A lot of people don't realize that modern physicists know this because Einstein's theory said this, and we're all based on that. And well, that was in 1910. And it was up until about 1980. And I came along and started changing stuff. And by 1995, that wasn't really true anymore. And we knew better, but we were still experimenting. And now we're getting to the point where we're not just guessing about this. We empirically know that he was wrong. And we're proving all the time how he's wrong and how to fix it. But nobody has still come up with a unifying theory that explains everything. I have. Thank you, Avi Loeb, by the way, because if you hadn't done the math, I wouldn't have realized what your math was missing. And I wouldn't have realized what our... Therefore, see, it's all mathematical. I am a mathematician myself. I grew up doing the math, and I realized right away that you weren't accounting for all the variables. You couldn't. And my brain naturally struggled to understand all the variables of your equation because I had to in order to account for it. And I realized there were major holes in our knowledge of physics because I've studied all the vital areas involved to know that and know where the math is missing. And I started, all of a sudden, my brain just started putting together the pieces, and I realized it has to be light. It's the only thing that reaches far enough was the first thing that accounted for it. Because light is from our sun is the only thing reaching far enough to actually account for what we're seeing. In addition, it is generating these charged particles, and we're failing to account for that overall. And when my brain started to put together the effect that has to have, I mean, it's a known quantity how these things interact and how these things will work. I studied electricity. I worked with my whole life, and I've studied light and worked with that my whole life. And between the two, they're my two major areas of expertise, and they are the reason I know, 100% know, that this is how things really do work in the universe. Now, the Earth, all the planets, we are bipolar, which means no matter which charge it picks up, it's still going to be both repulsed and attracted to a planet. Now, the trick is if the majority charge is, let's say, positive and the object is positive, it'll be pretty heavily attracted to that. But that's usually not how it'll be. It'll be there was a positive charge and the negative is usually stronger. So, because the outer field is negative, but the inner field is increasingly positive, this will start to take on a positive charge and itself behave like a bipolar magnet because it has a core that is negatively charged. And then on the outer side, we start pushing a positive charge. No, it loses that negative charge and it's pushed aside by a positive charge as it pushes through a positive field. And that is what will end up happening because it's not a magnet. It's not retaining that charge on its own. It's transitional. So you got to look for that too. There's going to be times when it gets tricky, like electromagnetism, because it's in that transition phase, especially when it first comes into that positive sphere of energy. And then as it travels towards our magnetics, it's basically like no matter which planet it wanted to point towards, it's a electromagnetic ball, positive and negative, which means it's going to be attracted one way or the other and help to push that circuit. And it's like, no matter how you think about it, when you start thinking about it in this terms, it only works positive and negative. And no matter how you do the math, it actually works